Collabora has been a leader in IT staffing for over 25 years and is one of the largest diversity IT staffing and services firms in the industry. Collabora TACT, or Technology Academy for Competency Training, is an effort to fill the talent gap which is widening with the emergence of new technologies. Collabora's data science training is poised to cater to the burgeoning demand for data scientists across industries. It has been said that data scientist is the coolest job of the 21st century. A McKinsey study predicts that by 2017, the US could face the shortage of almost 200,000 people with deep analytical skills. Why has there been a sudden surge and buzzword around data science? The right answer is that over the past few decades, there has been a massive explosion in the data generated, not only by companies, but also by devices, sensors, and of course, humans. Sometimes we call this big data. Data scientists are the people who make sense out of this data and figure out just what can be done with it. A good data science professional needs to have multiple skills, ranging from statistics to programming language to machine learning and data visualization, and of course, domain knowledge. Hi, my name is Kunal, and I'll be your data science instructor for this course. I have almost 10 years of industry experience across multiple domains. I have worked on multiple analytics projects and have provided end-to-end solutions to my clients. Whether you come from marketing, human resource, medicine, or any other non-technical background, it's perfectly fine because I'm going to teach you the ins and outs of data science in this course and help build your data science DNA. So let's get started. I'll walk you through the course contents. So let's talk about the genesis of the data science. It dates way back in 1980s, when actually there was only reporting which used to happen. So you can see usually, it was sort of, static and interactive reporting. Then during 1990s, what happened? The analysis was done mainly using Excel and, OLAP. And in 2000, there were some dashboards, and people used to, started building some dashboards to make sense what exactly, data looks like. Then during the 2010, now what will happen? That means now the analytics, professionals were keen to find what is going to happen in the future, right? So this was the time where data mining gained prominence, and also, along with the knowledge of statistics and other, analytics tools. So just take a look at the legends here. So let me set the prelude here. It all began with an HBR article on data science, featured in October 2012. DJ Patil and Jeff Baker coined the term data science, and data scientist ranks #1 in Glassdoor's 50 best jobs in America in 2017. Now let's take a look at, what exactly is data science. So data science is a multidiscipline, a subject in which you need to have knowledge of multiple subjects, starting from statistics to programming skills such as R or any other language. Then you have you need to know the machine learning techniques or the models. Then domain knowledge is equally equivalent. Whether you are from finance domain or marketing or supply chain, you need to know the ins and outs of that particular domain. Then comes the data visualization. No matter, let's say you have created some models, but those technical findings, unless you are able to translate that into a format which can be easily understood by the clients or end users, it may not make sense. So data visualization plays a very important role when it comes to creating reports and showcasing the results to your stakeholders. And finally, we have something called big data. So big data is also a part of data science, since we have a deluge of data, right? So much data is there currently, and country is creating some big data ecosystem just to do data crunching. Now this Venn diagram shows like what are the skill sets of a typical data scientist. So you can just take a look. It is a mixture of both computer science, machine learning, maths and statistics, traditional software, subject matter expertise or domain knowledge, Then you have something called traditional research. That means it can be secondary research. And finally, at the intersection, you will see there is something called unicorn. That means a real or true data science professional is almost similar to a data unicorn, right? So very difficult to find a true data science professional. Now let's talk about the analytics spectrum. So you can see here we have listed a couple of analytics spectrum. So analytics can be used in a wide range of fields. For example, you can use it in the text analytics. It can be used for in the social network analytics. Let's say you're doing some Twitter sentiment analysis. Then let's say we have something called time series analysis, and this is very important when it comes to analyzing data, especially in financial domain, in which you need to do some sort of revenue forecasting, or let's say you want to do some working capital forecasting, something like that. So in that case, you're going to use time series. Then we have supply chain analytics, and this will include a lot of analytics use case. For example, inventory optimization. It can be route optimization, and it can also be demand planning. Then we have something called pricing and promotion analytics. And in this case, it is very important. I mean, all the price elasticity and even the customer segmentation and cross and upselling using the techniques such as market basket analysis or association rule mining will come under this pricing and promotion. And finally, we have something called customer churn modeling. So especially in telecom, right? So if you want to predict, predict like when is a potential customer going to, exit your firm and join a competitor's, business, and that is where customer churn modeling is very important. So these are few of the test scenarios. These are few of the use cases. While there are a huge, humongous number of other analytics use cases. Then we also have credit card fraud detection, right? So let's say if a bank wants to predict whether this particular potential applicant is going to, default on the particular credit card or not. So that will come under credit card fraud detection. Then we have something called image analytics, and I mean you can use the image analytics to predict whether that particular image is of an animal or a human or a particular thing. Now let's talk about the data science workflow. And you can see data science workflow starts from right from the framing the opportunity. So this is the most important aspect of data science workflow. You need to have a real business use case. So you need to, under framing the opportunity, you need to be very sure like how you're going to quantify your business problem. Whether like whatever your solution is going to help the business in increasing the revenue Y by let's say 5%, or let's say it is going to result in savings by let's say $1 million, something like that, right? So you need to frame the opportunity, and after that comes the working with the data. So once you have framed the opportunity, the second important phase is you need to have proper data. So this is called data acquisition phase, and it is a very challenging phase because it is said that almost 70% of the time is consumed by in just to get the proper data set and transforming it into a format which is compatible with the analysis. So all the scoping of the data and data acquisition, in fact the data wrangling will come under this working with data. After that we have guiding the analysis. So you need to decide what type of techniques you are going to use to get insights from the data, whether it is going to be descriptive, diagnostic, or let's say predictive, or it can be prescriptive, right? And also you need to select proper tools for analysis. So you can go for let's say R, which is an open source tool to do the analysis, or any other statistical tool for that matter. And the final phase is storytelling. And this is the most important phase, because unless you are able to translate your findings into a visual format which can be easily understood by your stakeholders, all your efforts during all the preceding phase, it may end up in vain. So please ensure that all your technical findings need to be presented in a format that can easily be understood by your stakeholders. So very likely, very similar to the storytelling. Now, essentially in data science, we have two different types of variables. One is continuous and categorical. Now, in case of continuous, you can see we have continuous variable, as you can see in this box, 325, 3.14. Now we have categorical variable, which can be broadly classified into two subparts, which are called nominal and ordinal variables. Now, as you can see, it is self-explanatory that a nominal categorical variable doesn't have intrinsic ranking or order. On the other hand, an ordinal categorical variable, as you can see here, there is some sort of inherent ranking. And that's the fundamental difference between the nominal and ordinal categorical variable. We'll also talk about descriptive statistics. And before coming to the statistic part, let me tell you, in this particular course, we have the whole statistics course is divided into two parts. The first is descriptive statistics, and the second is inferential statistics. Now, descriptive statistics, it mainly helps you visualize the shape of your data. So that, let's say you have some raw data, and you would like to know how does your data look like, whether it is scattered or whether it is clustered, whether there are some outliers or not. And it's very important, during the initial analysis. And also, on the other hand, we have inferential statistics, which is used in cases when you want to infer the properties of a population based on a sample. And that's also a very important part of statistics. And we are going to cover in depth both the descriptive and inferential statistics, because statistics is the foundation of data science, and that's the prerequisite, or I would say it's one of the most important skill set you should have before you can master other areas in data science. So in descriptive statistics, we are going to cover a lot of important topics, such as measures of central tendency, under which we'll cover mean, median, mode. Then we'll have measures of spread, under which we are going to cover range, quartiles, interquartile range, and variance, standard deviation also. And this is called something, the power of 8. So these are some of the important metrics which will suffice your analysis of any type of data. Then we'll also talk about the tools which we are going to use for data science. So R, as you know, is the de facto tool for data analysis. So currently it is one of the most powerful analytics tool used across industries and also in academies, right? So it has a very strong community base. The tool is highly versatile. You have hundreds and thousands of packages which will help you, create or build models for any scenario, right? So that is why R is one of the most popular analytics tool currently, across industries. So in this case, we are going to use R. Now, as you can see, there are some of the reasons why R is so important. So it is free and it has a strong user community, and at the same time it is versatile, that caters to diverse requirements. So it is used in academia, tech companies, healthcare, manufacturing, and consulting firms. So we'll tell you how to install R, and then we'll go to the data structures of R. So data structures in R are the building blocks of in R, and these are the important data structures. So we'll start off with vector, then we'll go to matrix, list, and data frame. Now, one thing with vector is, right, so vector is the fundamental building block of any coding in R. So it is essentially a sequence of data elements of the same data type. So either we will have numeric or, let's say, characters, so it can have logical, it can be a logical vector also. Then we'll also talk about recycling, and we'll also talk about a two-dimensional array, which is matrix, and then finally we'll talk about the data frame, which is the most versatile data structure. And this is the data structure which we are will be readily using it to build our data analytics models, right? So there are other data structures. For example, we have list, and of course this is something called factor. So in R, any variable, if you want to convert into a categorical type, you need to use the factor, right? So you can see here, it is a collection of both the ordinal and the nominal type of categorical variables. So we'll talk about the logical operators, and then we'll also cover functions and loops, right? So we'll talk about a couple of inbuilt functions such as rep, sequence, and set.seed, and other inbuilt functions. And then we'll come to the user-defined functions. So I'll show you how to create the for loops using different use cases, and we'll talk about the while and for loop, and finally we'll talk about the break and next. These keywords which are most often used in the loops. Then we'll proceed to the data import in R. So data import is one of the simplest topics in R programming. So we'll tell you how to import data into R programming so that you are ready to do analysis. So either you can do it manually, or you can also write a couple of commands to import your data set. So your data set can be in any type of format, but predominantly it is going to be in .csv or .xls, or it can be in .txt format. Now, this is one of the most important, I would say, phase before you start building your model, and this is called exploratory data analysis. So these are the important functions, or I would say, important features of exploratory data analysis, which we are going to use while analyzing any raw data initially. Then we'll also talk about the data visualization. So this is the basic data visualization, and we are going to cover scatter plot, line plot, histogram, box plot. So box plot is very important when you do univariate analysis, because it helps you figure out the outliers, if there are any outliers in your data set. Now, so we are talking about covariance. So this is important when we talk about our first machine learning algorithm, which is called linear regression, right? So just take a look. So we have covariance and coefficient of correlation. Now the only difference between covariance and coefficient of correlation is that the coefficient of correlation is standardized. So you need to divide the covariance by the standard deviation of x and y. And moreover, please remember that the range of correlation lies between -2 to 1, unlike covariance, which ranges from -infinity to +infinity. We'll also talk about the regular expression, and this is one of the important topics in data science, especially when you are going to do some sort of sentiment analysis. So we'll take an example of Twitter sentiment analysis, and we are going to implement a lot of learnings of regular expression. So we'll do a couple of important exercises in regular expression. Then we'll proceed to the database access. So it is possible to connect your R interface. In this case, we are going to use RStudio. So how we are going to connect RStudio with other databases, essentially your relational databases. For example, it can be SQL Server or Oracle, right? So these are the important functions which you can use to access your database. After that, we are going to talk about grammar of graphics. And so this is very important because it provides a very systematic way in which you can build your data visualization. And this topic comes under advanced data visualization. So we'll talk about the anatomy of bullet chart, and then we'll talk about the grammar of graphics. As you can see, it has these important components starting from data, aesthetic, geometrics, statistics, facets, coordinates, and themes. And this is important because we have, when we'll cover ggplot2, which is one of the most powerful data visualization package in R. This will come in handy because ggplot2 has been created based on these underlying principle of grammar of graphics. We'll also talk about the apply family of functions, which are very popular, and it gives you a shortcut to do a couple of important functions in R. We'll also talk about the difference between lapply versus sapply. So lapply, remember the fundamental difference between lapply and sapply is the output of lapply is always going to be list. So there's another more versatile apply family of function which is called tapply, and we'll use the use case of iris dataset to do some calculations using tapply. Then we'll talk about one of the most important package. I would say it's a very powerful package for data wrangling or data munching, and this is called dplyr. So dplyr has been created by the prominent data scientist called Hatley Wickham, and who happens to be the chief data scientist at RStudio. And it's a very powerful and versatile package, and we'll see how all these functions of dplyr you can find the similarity with your SQL. So we'll talk about select, filter, arrange, mutate, summarize, and of course the join functions. Then we'll also cover the topics on some basics inferential statistics. So as you can see, Inferential statistics, essentially it means you're trying to infer the properties of a population based on a sample. We'll talk about the normal distribution, and you can see if here we have a bell curve, and we'll also talk about 68, 95, 99.7 rule, and this will help you understand the confidence interval better. So these are some of the properties of the Bell or the Gaussian curve, and we'll work on few examples. Then another important topic is standard error. So we'll see what is the difference between standard deviation and standard error. And we'll also talk about the central limit theorem. And then we have the confidence interval. And one of the important topics in inferential statistics is hypothesis testing. So I'll help you demystify the concept of hypothesis testing. So these are the typical steps involved in hypothesis testing. So we'll also tackle a couple of questions on hypothesis testing. Then we'll proceed with the data mining. Right. So as you can see, data mining, this is one of the way in which you can explain your data mining process. So essentially, in the input side, you are giving some raw data, and from the output, you're trying to derive some actionable insight. And whatever goes inside the process, there can be a lot of process. For example, business analysis, data collection and validation, data cleaning and transformation, model creation and validation, and finally the model deployment. And finally, then we are going to talk about machine learning, and this is going to be the most exciting topic in the whole course. Now, what exactly is machine learning? So I'll give a very simple example to illustrate the machine learning. We'll also take an example of a human. So this is a human analogy to explain the concept of machine learning. And then we have something called supervised machine learning. So the fundamental difference between supervised and unsupervised machine learning is, in case of supervised machine learning, you already know the target variable or the objective in advance. While in case of unsupervised machine learning, you're not aware of the objective or the target variable. So machine learning techniques such as clustering typically falls under unsupervised machine learning, because you are not aware in the beginning how many clusters you are going to create, right? Now we'll start off with the most fundamental machine learning technique, which is called linear regression. And we'll cover all the important formulae and the parameters. Essentially, we'll cover the covariance, the coefficient of determination, and correlation coefficient. We'll also talk about the line of best fit. And then we'll also talk about measures of accuracy. Right, so there are different measures of accuracy. You can use root mean square error, or also you can use mean absolute percentage error, right? So there's something called MAPE, and that's a very important measurement of accuracy in case of linear regression. So there is something called assumptions of linear regression, and why this is important, because before you are presenting your linear regression model to the stakeholders, so it is important that you need to validate the assumptions of linear regression. If any of the assumptions is violated, then it may not be reasonable to go ahead with the creation of linear regression model. So we'll see what are the assumptions of linear regression, and what are the different tests available in R programming to validate these assumptions. Then we will cover a couple of interesting topics under inferential statistics, which is going to be advanced. So we'll talk about what is the fundamental difference between Z statistic and T statistics. So remember, whenever you have the sample size, if it is less than 30, right? So in that case, T statistics is a better, way of capturing the values. We'll also talk about the T distribution, and we'll compute some confidence intervals using the T-scores. Now, the T, we'll talk about the dependent T-tests and independent T-tests. So I'll give you some interesting examples, like how do you differentiate between dependent and independent T-tests. We'll talk about the Cohen's T, and you can see this is the R code for the dependent T-test. Okay, and this is one of the most maybe misleading misleading topic in statistics, but it is nonetheless it's very important. So this is called ANOVA, which stands for analysis of variance. So I'll give a very good example of ANOVA, and we'll see uh, how we are going to understand. I mean, what are the parameters we need to look at while understanding ANOVA, right? So these are some of the features of ANOVA assumptions. It should be normally distributed, and the observations need to be independent of each other, and finally there should be equivalent variance. So we'll take a look at an example which explains in detail the underlying principles of ANOVA. So we'll calculate the entire exercise. We'll do the computation, and I'll show you. Then we'll move to the next, a type of machine learning model, which is called logistic regression. So logistic regression and subsequent, machine learning algorithms will fall under classification. So this is a different category of machine learning in which you are essentially trying to figure out, based on historical data, you need to predict whether that particular, object is going to fall into which of these categories. So logistic regression essentially, it tells you, about binary classification or dichotomous classification. So we'll go through the examples, and there is something called confusion matrix, and this is one of the important evaluation parameters which is used in logistic regression. So we'll discuss in detail about confusion matrix and why it is significant, right? So we'll spend quite some time on confusion matrix, and then also we have something called ROC curve, which is one of the ways in which you evaluate your classification model, whether it is logistic or any other classification model. Then we have something called precision recall. So in order to have, in order to be sure like your logistic regression model is really good, you need to create this chart called precision recall, and you need to achieve a trade-off depending on the problem statement. Then we'll talk about the clustering techniques, and the two techniques which I'm going to cover in this machine learning algorithm is going to be k-means and hierarchical clustering. So we'll start off with k-means clustering, and I'll explain like how does the k-means clustering works. So under the hood, how the algorithm runs. So we'll also try to find the optimal number of clusters, and we'll talk about the hierarchical clustering. So hierarchical clustering, it gives you a tree-like structure. So it's a dendrogram, and you can see we can use different types of linkage methods to create our hierarchical clustering. Then we'll talk about association rule mining and why this is important. So imagine this is especially important in marketing parlance. So let's say it will help you, the marketing team, or let's say the sales team, to organize or place their merchandise better. So this is also called market basket analysis, and it can be used successfully to do some sort of cross-selling or upselling of your products. Then we'll talk about a few other classification techniques, such as decision tree. So we'll also talk about a few problems, common problems such as overfitting and underfitting, and we'll also see how the decision tree actually works. So there are a few important parameters in case of decision tree, such as you need to measure the impurity using entropy, Gini index, or classification error, and then you have to compute the information gain in order to figure out, where should the decision the decision tree should be split at which node. Then we'll talk about a more advanced technique, which is a part of ensemble method, which is called random forest, and we'll explain the basic principles of random forest, and we'll do the coding, everything in detail. We'll move to other classification techniques such as naive Bayes, which is essentially based on the Bayes theorem. So you can see the naive Bayes contains these four important parameters. So you have posterior probability, you have the likelihood, you have pride, and finally the marginal. We'll also talk about the k nearest neighbors. This is another classification technique. It is simple but yet very powerful. So we'll see how the k nearest neighbor works. And then this is one of the most important classification technique, and this is called support vector machine. So support vector machine can be used for both classification and regression. And I'll also explain the intuition behind support vector machine, which is essentially based on hyperplane. So creating a hyperplane which supports, which, or let's say which divides the two clusters properly. So it is based on the concept of maximum margin and support vectors. And it has a very important feature which is called kernel trick, which helps you map your data in low dimension to a higher dimension, so that the data set is easily separable. Then also we'll talk about artificial neural networks. So neural networks, essentially it mimics your human brains, right? And it has neurons which are the main components of neural networks. So we'll talk about the activation functions. So though there are different activation functions such as step function, sine function, and sigmoid function, I mean, it's up to you, and it depends on the scenario, like which activation we are going to consider. So weights and biases are the important components of artificial neural networks, and layer wise we have input layers, hidden layers, and output layers. Now time series is one of the important topics in machine learning. So especially in finance and in econometrics, time series is really important. So we'll cover the ins and outs of time series, starting off from a simple moving average. Then we'll proceed to the exponential smoothing. We'll also cover Holt-Winters techniques, and finally we'll cover some advanced techniques such as ARIMA, which stands for Auto-Regressive Integrated Moving Average. And we'll also discuss some of the important properties of the time series. Next, we'll see, like, whatever we have learned in regular expression, we'll try to implement that, the findings or the learnings of the regular expression while doing the sentiment analysis. So we'll take Twitter example, and we'll do Twitter sentiment analysis on some very historical event, and we'll see what is the overall sentiment of the people. Then we'll see how we can create some professional reports, right, which can be shared with different stakeholders using R programming. And this is something where R Markdown is going to be very helpful. So using R Markdown, you can easily create documents in Word format, or let's say the PowerPoint presentation, and even PDF format. Then we'll also talk about the recommendation engine. So just imagine when you browse through the Amazon, and when you select a particular product, and at the bottom you will see people who selected this also selected, have also selected or have also seen these products. And that is where the recommendation engine works, right? So we'll talk about the important recommendation engines. For example, collaborative filtering. There are two types. We have user-based and item-based collaborative filtering, and I'll explain how it works. And finally, right, so we'll wrap up our course by explaining some of the important features of big data, and essentially we'll be focusing on Hadoop ecosystem, right? So we'll talk about query engines, external data storage, and so this is a core Hadoop ecosystem. We'll discuss about all the components of the core Hadoop, and we'll also discuss a little about the proprietary vendors. So we have Cloudera and Hortonworks. So we'll discuss a little about these two vendors. Yes. So with this, I would like to wrap up this session, and I hope you are familiar with like what are the important topics we are going to cover in data science. So it is going to be very comprehensive, and the topics are, we'll start off with the basics, and then we'll move to the most sophisticated topics, and we'll provide you a lot of assignments and also a lot of real examples, and I will ensure that that the session is going to be more interactive. So thanks for your participation. Goodbye.